Hey guys, today we're building a full stack feedback form app. In this video, we'll build a backend using Express, give the backend a clean structure, set up Prisma ORM and store feedback in a real database, add server-side validation using Zod, and connect the backend to the existing frontend. By the end, you'll have a fully working feedback form application running end-to-end. So let's jump in. Okay, let's start by creating a brand new Node.js project with TypeScript. I've got an empty folder open in VS Code since we're gonna build the backend from scratch. And I also have the Prisma SQLite Quick Start open in the browser. We'll be using Prisma in this app, but for now just a reference while we get this server up and running. First I open the terminal in VS Code, and I'm gonna create a new folder called server. Then I'll navigate into it. We'll start by initializing a Node.js project using npm init-y, which creates a package JSON. The -y flag just sets all the fields to their default values without asking any questions. Now let's run that. And here we can see the package JSON file. Next we'll run the command to install the TypeScript tooling. So here we're installing TypeScript itself, TSX, and the node type definitions, all as dev dependencies. And TSX is just a tool that lets us run a Node.js app written in TypeScript during development. After that, we'll initialize TypeScript. So we're gonna run npx tsc --init. And it creates the TypeScript config file, txconfig.json. Next, we move on to the configure ESM support section of the Prisma docs, and we're gonna apply these changes exactly as they're shown here. So this way we're gonna add ECMAScript module support to our project. First we'll update the TypeScript config. The module option will be set to ESNext. And we're gonna add module resolution bundler. The target will be ES 2023. And strict true is already there. So let's add the last two options at the end. Next we'll open package JSON. And we'll add type module to it. Okay, with that in place, let's create a new folder inside server called src. And then an index.ts file inside. And for now, we'll just console log a simple hello message inside this file. Next, we'll add a dev script using tsc in watch mode to package JSON. So let's remove this one. And we'll say dev. And the command is tsx watch. And the target file is src index.ts. Now let's run the project, and we can use the command we've just added. So we say npm run dev, and we can see the hello message printed out in the terminal. Since the project running in watch mode, the server will automatically restart whenever we make changes to the code. And if I add a simple exclamation mark at the end, We can see the updated input right away. So at this point the server is running, TypeScript is working, and we've got a clean starting point for the backend. Let's move on and create an Express server. First we'll stop the current command with Ctrl+C in the terminal. Now let's install Express and the Express type definitions. Express itself goes into regular dependencies, so we say npm install Express. Here we go. And the types go into dev dependencies, so npm install -d add types /express. Now let's go back to index.ts, and we're gonna replace this temporary console log with the basic Express setup. First we'll import Express. And then we'll import the request and response types from Express. So import type, request and response. Then we'll create an Express app instance. So const app, and we're gonna call Express. Next we'll specify the port. And I'll choose 3000 for now. Then we'll add a simple get route on the root path. So we say app.get, and it's gonna handle get requests. It takes 2 arguments. The first one is the path, in this case it's just /. And the second one is a handler. It's gonna be an arrow function. And it takes a request object of type request and a response object. And for now we'll just return a small JSON message so we confirm the server is responding correctly. So inside the callback, let's say response JSON, and we're gonna return a small object with the message property, and let's just say feedback form express backend. After that we'll run this server by calling app.listen. And we're gonna pass the port as the first argument. And the second argument will be a callback. Inside the callback we'll say console log. And then in backticks server is running on http column / localhost column $ curly braces, and we'll put the port value inside. And this callback will be called when this server is running. Now let's run it. We'll start the dev script again, so npm run dev. And in the terminal we can see that the server is listening on port 3000. If we open this URL in the browser, we get the JSON response back. So now we've got a basic Express server up and running. Alright, let's give the app a bit of a structure. First, let's define a feedback type so we know what our feedback data looks like. We'll create a new file at src types feedback.ts. And we'll add the feedback interface there. And I'm just gonna copy that. But this is just temporary. Later on we'll replace it with the type generated by Prisma. Now let's add a route to handle feedback submissions. Inside src we'll create a new routes folder. And inside that a feedback routes.ts file. Inside this file we'll create a new Express router. So first let's import router from Express. Then we'll import the request and response types from Express. Next we'll create a router instance. And then we'll add a post route on the root path. So we say router post. And the path is just slash. Next we've got the handler. And as usual it takes a request object and a response object. Inside the callback handle we'll just log the request body. So console log. And we'll say received feedback. And then we're printing the request body. And let's return a simple response. So res JSON. So it's gonna be an object with the message that just says feedback received successfully. And this should be a response. After that, we'll export the router. Backend index.ts will import the feedback routes. So import feedback routes from routes, feedback routes. And let's add a comment saying routes. And we're gonna mount the feedback routes under API/feedback. So any post request to that path is handled by our new router. We'll say app.use. The path is /API/feedback. And the second argument is our feedback routes. Finally, we'll add the JSON middleware to Express. This will let us read JSON data from incoming requests. So above routes, we'll say middleware. App.use. And in this case, the middleware is the value returned by express.json call. And we can actually send a post request with the feedback object in the body to see if everything works. There are a bunch of ways you can do this. I'm just going to use the Thunder Client extension in VS Code. So there it is. But you could totally use something like Postman or any other REST client you like. I'll go ahead and open Thunder Client. And I'm gonna create a new request. The method will be post. And the URL will be http localhost 3000/API/feedback. Now I'm gonna add the request body, which is just gonna be a sample feedback object. Let's go ahead and send it off. And we can see the result. Also in the terminal we can see the request body being logged. The response comes back as expected, which tells us the route is working. So at this point we've got a dedicated endpoint ready to accept feedback submissions. Now let's introduce a controller to handle feedback submissions. So far our route is handling the request directly. That works, but as the app grows we want to keep routing and request logic separate. So inside src I'm gonna create a new folder called controllers. And inside that a file called feedbackcontroller.ts. In this file we'll create a feedback controller class, so class feedback controller. And we're gonna add a create method which will handle incoming feedback submissions. It's gonna be an asynchronous method. And it takes a request and response object as parameters, so request. And we wanna import this type from Express. And the same goes for response. Inside this method, we type the request body using our feedback interface. So we say request body as feedback. And we're gonna store this object in a feedback variable. And for now, we'll just console log that, so we can see the data is coming through the controller correctly. So let's say console log received feedback in controller, and then the feedback object. After that, we'll send a success response with the 201 status code. So response status 201 and JSON. And let's say success true. and message feedback submitted successfully. Finally, we'll export a single instance of the controller. So we say export default new feedback controller. Now let's update the route. Backend feedback routes will import the instance we just created. And we're gonna replace the inline post handler with the call to feedbackcontroller.create. And we're passing in the request and response objects as arguments. So the route stays focused on routing and the controller handles the request logic. And if we go to Thunder client again and make another post request, we can see the log coming from the controller this time, and the response comes back as expected. So at this point, feedback submissions are handled through the controller. Now let's introduce a service to handle feedback logic. Currently the controller is still doing too much. It's receiving the request and also deciding what to do with the feedback data. To separate those responsibilities, we'll move the feedback handling into a service. Inside SRC, we'll create a new folder called services. And inside that, we'll create a feedback service file. In this file, we'll create a feedback service class. For now, we'll add a single save method, and it's gonna accept a feedback object. Let's make it asynchronous. And let's specify the return type, which is gonna be an empty promise. Right now, just gonna log the feedback to the console. So let's say console log, saving feedback, and then the feedback object. And we'll replace this later with real persistence. Now we'll export a single instance of this service. So export default new feedback service. Now let's update the controller. Backend feedback controller, let's import the service instance. And right below that, we'll define a type that represents the shape of our service. So we say type, and let's call it feedback service type. Then we'll use type of, and then we'll use the service instance. Next, inside the controller, we'll add a constructor that receives the service instance. So we say constructor feedback service of type feedback service type we defined above. And let's mark it as private. By doing that, TypeScript automatically creates a private member on the class and assigns the value for us. And I'm also gonna update the export to pass the feedback servers into the controller. Here we go. So this way the controller doesn't create the service itself, it just uses it. So here we're basically doing a really simple form of dependency injection, but don't let this fancy term scare you. We're just passing the server's instance into the controller's constructor instead of creating it inside. And if you're using a framework like Node.js, it normally handles that for you, but here we're just doing it manually ourselves. Okay, inside the create method, let's replace this console log with a call to the save method of the service. So let's say await, and we can access the service instance using this feedback service, and we'll pass the feedback object in. Let's also add a comment saying save feedback using this service. Everything else in the controller stays the same. If we go to Thunder client and make another post request, we can now see the log coming from this service instead of the controller. At this point, the responsibilities are clearly separated. The route handles routing, the controller handles the request, and the service handles the feedback logic. Now it's time to bring in Prisma and set up the database layer. I've got the same guide open that we used earlier, but now we're actually gonna set up Prisma with SQLite. First we'll install the required dependencies from the guide. So I'm gonna copy these commands. Then I'll stop the dev server and I'm gonna run them in the terminal. Once that's done, we'll initialize Prisma. So we're gonna run the Prisma init command with the SQLite provider and a custom output path. So let's copy and run that. This command created a few things for us. It created a Prisma directory with a schema.prisma file inside. This file defines the database connection, and that's where we'll define our models. It also added a .env file for environment variables, and at the moment it only contains the database URL value. Lastly, it also generated prisma.config.ts file for Prisma configuration. Next, we'll define our data model. In the quick start example, they use user and post, but in our case, we'll define a single feedback model. So let's go to schema.prisma file, and we're gonna define our model down here. I'll just copy and paste it. Now let's quickly go over it. We also have an ID field, which is an auto-incrementing integer primary key. That means Prisma will automatically generate a new value for each record. Then we have name, email, and category, which are all strings. Rating is an integer. Message is also a string. Notify is a boolean, so it stores either true or false. And finally we have created add, which is a date time field. It uses default now, So Prisma will automatically set it to the current time when a new record is created. After that, we'll create and apply our first migration. So let's grab this Prisma migrate dev command. This generates the SQLite database file and creates the feedback table based on our schema. Let's run that. Once the migration finishes, the database file is created and we can inspect it. Since we're using SQLite, there are VS Code extensions that let us open the database file directly. I'll use the SQLite Viewer extension, and I can simply click the file to open it. And if we look at the tables, the feedback table has been created. It's empty for now, but everything is set up and ready. It contains all of our fields. Prisma also offers a universal way to explore your data called Prisma Studio. It works with SQLite, Postgres, and other supported databases, and we'll use it in a moment. Next, we'll run the command to generate the Prisma client. So we're gonna run npx prisma generate. And now we can see the generated folder inside server. Then we instantiate the Prisma client. I'll create a new file at src-lib prisma.ts. Next, I'll copy the code provided in the guide. We just need to adjust the path to the generated client since we're inside the src folder. So I'm gonna add ... at the beginning. In this file, we'll load the environment variables, create an SQLite adapter using the database URL, and pass it into the Prisma client. Lastly, we export a single Prisma instance that we can reuse throughout the app. Now let's open our database in Prisma Studio. I'll open a second terminal tab in VS Code, and I'll navigate into server. Then I'll run this command npx Prisma Studio. It opens a browser-based interface where we can view and manage our data. And here we can see the same feedback table we saw earlier in the SQLite Viewer extension. Okay, at this point Prisma is fully set up, the database is created, and we're ready to connect it to our service layer. Now let's replace the temporary console log in our service with the real database call. Inside feedback service, I'm gonna import the Prisma instance we just created. Let's remove the console log and we'll say await prisma.feedback.create. We'll pass the feedback object into the data field, just like that. Let's also add a comment, save to database. And that's it. Prisma takes care of generating the correct SQL behind the scenes and inserting the record into the database. Now let's test it. First, we need to start the dev server again. So npm run dev. Now let's go to Thunder client and let's send another post request. If everything works correctly, the record should be saved in the database. I'll go ahead and open the database file using the SQLite viewer extension. And if we select feedback, we can see the record is actually there. So that worked. Now let's go to Prisma Studio, and if we refresh, we can see the same record in the feedback table. I'm gonna send a couple more requests. So let's go to Thunder client again. And let's send this data. And one more. And if we refresh the table again, we can see the new records in the feedback table. Right now we're accepting whatever comes in the request body. That's not something we want in a real application. Input should be validated on the server before it's saved. We'll use the Zod library to validate the structure of our incoming data. So first let's install it. I'm gonna stop the dev server and I'll run npm install Zod. Next, inside src, I'll create a new folder called validators. And then a feedback validator file inside. And this file will define a feedback schema using Zod. First we'll import the Z helper from Zod. Then we'll say export const feedback schema. And then we'll call the object method on Z. It accepts an object with the validation rules. And I'll just copy it. We validate that name is a non-empty string, and if the validation fails, the error message will be name is required. For email, we use the built-in email method provided by Zod. Category also must be a non-empty string. Rating must be an integer between 1 and 5. Message is also required to be a non-empty string, and notifier is required to be a boolean. Now let's update the controller. We'll import the feedback schema we just created. Then inside the create method we'll comment out this line, and below we'll say validate request body. And we're gonna call the save parse method on the feedback schema object. So feedback schema dot save parse. And we'll pass in the request body. It returns an object that represents the validation result. So let's say const validation. it has a success property, which is set to true if validation succeeds. So let's check if validation fails. So if it's not true, then we return a 400 response with the validation error messages. So response status 400, then JSON. We're gonna return success false. And then we'll add errors. Let's say validation error issues. We're gonna map them. And from each issue, we'll return the message property. Then we'll just say return. Now, if validation succeeds, we'll use the validated data directly. So in this case, we'll say const feedback, and it's gonna be equal to validation.data. Now let's go to the Prisma client, and we're gonna import the Prisma namespace from the generated client, and then we'll export it. It contains the Prisma types we're gonna use. Now let's go back to controller, and we can remove the interface we import up here. We can also remove this commented line. Now let's open the source file, and here we can also remove the interface we import, and we'll import the Prisma namespace from libprisma. And we'll replace this feedback type with Prisma feedback create input. And now we can completely remove the types folder. So that way our types now come directly from Prisma and not from manually defined interface. Now let's test it. So let's start the server. And if I go to Thunder client, and let's say try to submit a feedback with an empty name, I'll get the name as required error. And if I refresh the table, it was not saved to the database. And if we add a valid name, let's say John Smith, if we refresh, the feedback is saved as expected. So at this point, our API is properly validating input before writing anything to the database. Let's add a couple more routes to make our API more complete. Right now we can create feedback, but we don't have a way to retrieve it. We're not building an admin interface here, but this is the kind of endpoint you'd add if you were. First, inside the service, I'll add a new getAll method. And this time we're gonna use the findMany method on the Prisma feedback object. So inside we'll say return await, and we're gonna call prisma.feedback.findMany. And we'll also add an order by clause, so the newest entries appear first. So we're passing in an object, and it has a property called order by, which is set to another object with the property created at set to descending. Next, we'll open the controller file, and right below the create method we'll add a new getAll method. It also accepts a request and response objects. And inside this method we're gonna call the server's layer to get all the records. So let's say const feedbacks await this feedback servers, and we're gonna call the getAll method we just defined. Then we're gonna return the data in a JSON response with the 200 status. So response status 200, then JSON, and we'll set success true and data set to feedbacks. Finally, I'll update the routes file. So right below the post route, I'll add a new get route on the route path, and I'll connect it to the controller's getAll method. And I can just copy the post route, and I'll replace post with get, because this time we handle get requests, and also replace create with getAll. Now if we go to the browser and open localhost 3000/API/feedback, we can see all the stored feedback entries returned as JSON. Another route we'll add is a fallback route to handle 404 errors. So if someone accesses a route that doesn't exist, we want to clearly return a 404 response. So we'll go to index.js, and right below the feedback routes we'll say app.use, and we'll pass in a callback. It also accepts a request and response. Inside the callback body we'll say response status equals 404. Then we'll add type text, and we'll simply return not found. So that runs only if no other route matched, and returns a 404 with a simple not found message. So now if we go to the browser and open something like /test, we can see the not found message. So far we've been running this server using TSX in development mode, but in production we typically don't run TypeScript files directly. Instead we build the project and run the compiled JavaScript. To handle that, we're going to use TSUp as our build tool. First, in tsconfig.json, I'm gonna set the outdir to dist, so I'm gonna uncomment this line. This tells TypeScript where the compiled files should go. Next, I'll install TSUp as a dev dependency, so I'll stop the dev server, and I'll run npm install -d TSUp. And then inside package.json, I'll add two new scripts. So right below the dev script, we'll add a build script, which bundles the project using TSUp. And the command is TSUp, then src index.ts, and we'll set the format to ESM. Next, we'll add a start script, which runs the compiled file from the dist folder. So the command is node dist index.js. Now, if I run the build script, it will generate the compiled output in the dist directory. So let's run npm run build. And there it is. After that, we can start the server using npm start. And it will run the compiled JavaScript with Node. And now we can see the server is running. And to confirm it works, we can go to Thunder client. And let's send a GET request to HTTP localhost 3000 API feedback. And it should fetch all the feedback items we've got in the database. And here they are. At this point, the backend can be built and started the same way it would run in production. If you're interested in how the frontend was built, there's a dedicated video for that. The link is in the description, but you don't need to watch it first. I'll explain everything as we go. Now it's time to bring in the frontend we built in the previous video and connect it to our backend. This is where everything starts coming together into a full application. I have the frontend GitHub repository open in the browser. The link will also be in the description. So first I'll open a new terminal in VS Code. And I'm gonna clone the repository into this project and name the folder client. Let's copy the repo URL. And then in the terminal we'll run git clone, then the URL, and the folder name will be client. Now, since I want this entire project to live in a single repository, I'll remove the .git folder inside the client directory. So I'll say rm-rf, then client/.git. Okay, now let's navigate into client. And let's install the dependencies. So npm install. After that, I'll start the development server. So I'll run npm run dev. Once it's running, I can open the URL shown in the terminal in the browser. And here we can see the feedback form we built earlier. Now let's connect the frontend to the backend. Before wiring everything together, here's a quick recap. we have a feedback form with the following fields: name, email, category, rating, message, and a checkbox for notifications. The submission logic lives inside a composable called useFeedbackForm. Inside this composable, we manage the form state, handle submissions, and display notifications. Previously, the submission logic inside the composable was only simulated. Now we'll replace that with a real API call. First, let's update the comments about the sendRequest function. Now we'll simply say submit the form. Next, let's remove everything inside. And we'll use the built-in browser fetch function to send a post request to /API/feedback. So we'll say await fetch. The first argument is the URL. In our case, it's /API/feedback. The second argument is an object with options. We'll set the method to be post. Then we'll specify the headers. We'll send the form data as JSON. So we'll set the content type header to application JSON. Then we'll set the body, which is gonna be a stringified version of the form object. So JSON stringify form. This returns a response object. So const response. And this object has an OK property, which is set to true if request succeeds. So below we'll check if response is not OK. So if not response dot OK. Then we'll throw an exception. And the error message will be failed to submit feedback. Otherwise, we'll return the JSON response from the server. So return await response in JSON. Next, we need to configure the development server so the client can talk to the backend. Since the frontend runs on a different port during development, we'll add a proxy configuration in vite.config.ts. So right below the plugins option, we'll add a new one called server, and it's going to be an object with a proxy property, and inside we'll say /API, then HTTP localhost 3000. And let's add a comment proxy all/API requests to backend. So here we tell Vite to forward all requests starting with /API to HTTP localhost 3000. This way, when the client sends a request to /API/feedback, it's automatically routed to our Express server. Now let's test it. First, let's restart the client dev server just in case. And now let's fill in and submit the form. Let's say Frontend test. And let's set email to frontend@test.com. Let's select a category and a rating and a message. Now let's submit the form. And we can see the success screen and success notification. And if we go to database and refresh the page or refresh the table, we can see a new record. So that works. Now let's go back to the form and let's refresh the page. Now we'll try sending the form with an invalid field. Let's say an empty name. Since we have client-side validation, browser blocks that, but we can do a little trick here. We can go to the DOM inspector and we can remove the required attribute from the name input. And now we can submit the form. And we can see the error notification. And if we go to Prisma Studio and refresh the data, the new record was not added to the table, so that worked as well. So now the client and the server are fully connected. When we submit the form in the browser, the request goes to the backend, gets validated, and saved to the database. Now let's look at one way to make the client and server work together in production. There are multiple ways to deploy a full-stack app, but this is a simple approach where the backend stores the frontend as static files. First, inside the client folder, I'll stop the dev server, and I'll run the build command, npm run build. It came out of the box with the Vite project. That created a dist folder with the production-ready frontend assets. I'm gonna copy this folder into server, and then I'll rename it to static. Now on the server side, we'll go inside the server folder and we'll stop the dev server. Next, inside index.js, we'll import the file system module that comes with Node.js. So import fs from fs. Then right above the fallback route, we'll define a constant to store the path to the static directory. So we say const, and then in capitals static underscore dir, and the value is just static. Then we'll check if this directory exists, so if, and we'll use the existsync method from the fs module, so fs.existsync, and we'll pass in the constant as an argument. If it does exist, we'll make Express sort those files as static assets. And for that we'll say app.use, and we'll specify the path we want our static files to be served at. In our case it's just root, so slash. And the second argument, as the second argument, we're gonna call the built-in static middleware that comes with Express, so express.static. And we'll pass in the constant again as an argument. Let's remove the test route we previously added on the root path. And now the server can serve both the API and the frontend. To test that, we'll build this server and we'll start it in production mode. For that, we can use the commands we previously added in this tutorial. But first, let's remove the existing dist folder inside server. Now let's build the server, so npm run build. And next let's start it, so npm start. Now if we go to the browser and open localhost 3000, we can see our feedback form. Let's submit the form. So let's say static files test, and then static files at test.com. Okay, let's submit that. And if we go to the database, we can see the new record. So at this point, the frontend and backend are running together as a complete application. And that wraps things up for this video. We now have the entire app running end-to-end. If you found this useful, please support the channel by liking the video, sharing and subscribing. I'll see you in the next one.